Hello everyone, welcome to another learning video of pharmaceuticals. I am Imesh Mistry and today we will discuss on very common but very critical and sensitive point. Before going ahead, I would like to ask you a question. Do you know that there is an instrument which plays vital, major and significant role during the manufacturing activities as well as testing activities? And if any error occurs during the operation of this instrument, it may affect the manufactured product and there is no other way to save this affected product from being discarded with huge monetary loss. And if any error occurs during the testing activities, it may change the results of testing parameters. This instrument is mandatory and it is installed by all pharmaceuticals, whether they are manufacturers of different products, different dosages. Without this instrument, not even a single pharmaceutical can able to manufacture even a single product. Yes, I am asking about balances. Balance is very small in size, but its importance is very high. So today we will discuss the types of balances and calibration parameter of balance. Types and classifications of balances as per European pharmacopoeia and calibration as per US pharmacopoeia. I know you are here wondering why I am taking two different pharmacopoeias and mixing it up. So let us understand it. There are two general chapters for balances in US pharmacopoeias and those are USP General Chapter 41 and title of this chapter Balances and USP General Chapter 1251 and title is Weighing on Analytical Balance. But types and classifications are not given in both chapters. They are given in European Pharmacopoeia General Chapter 2.1.7 and that's why I am taking two different pharmacopoeias here. This video will be very informative for those who are working in pharmaceutical, those who are working in EP and USP based pharmaceutical and especially for those who are working in quality control department. So let's get started without any further delay. First, we are going to learn types and classification of balances. As per European Pharmacopoeia General Chapter 2.1.7, as per EP, balances are classified based on readability. This readability is also called scale interval. Readability and scale interval is defined as the minimum value which a balance can display and it is denoted by small d. Here, readability of this balance is 0.0001 and it is denoted by small d. So, minimum value is displayed by this balance is 0.0001 gram. Now, how these balances are classified based on readability? So, in this chapter 2.1.7, balances are classified into two types and those are precision balance and analytical balance. Analytical balance is again classified into three types and those are semi-microbalance, microbalance and ultra-microbalance. These classifications are based on this readability. So first, precision balance. Balance with readability from 10 raised to power minus 1 to 10 raised to power minus 3, then it is considered as precision balance. Here 10 raised to power minus 1 can be written 0.1 gram. 10 raised to power minus 2 can be written 0.01 gram and 10 raised to power minus 3 can be written 0.001 gram. Here you can see three balances. Balance number 1, balance number 2 and balance number 3. I want to give you brief description about all these balances. In balance number 1, there is one digit after dot and after point and we call it one digit balance. In balance number 2, there are two digits after point and we call it two digit balance. And in balance number 3, there are three digits after point and after dot and we call it three digit balance. All these balances are precision balance. Now, analytical balance. If a balance with readability 10 raised to power minus 4 then it is considered as analytical balance and it can be written 0.0001 gram and we call it 4-digit balance. Further, analytical balance can be of three types and those are semi-microbalance, microbalance and ultra-microbalance. Semi-microbalance. Balance with readability 10 to power minus 5, it can be written 0.00001 gram and we call it 5-digit balance. Microbalance. Readability 10 to power minus 6 can be written 0.5 times 01 and we call it 6-digit balance. Ultra microbalance. Readability 10 to power minus 7 can be written 0.6 times 01 and we call it 7-digit balance. All these balances are very sensitive and many factors affect its sensitivity such as direct sunlight, direct airflow, temperature, humidity, dust, vibration, etc. And the main thing is that all these balances must be installed on the anti-vibration table only. The purpose of all these balances is that as the number of digits is increased, accuracy level of weighing is increased. So these are the classification of balances. Now, if you want to weigh any material accurately, then weighing should be performed with the help of all these balances. But before that, we have to make sure, we have to confirm the accuracy level of all these balances and that's why we have to do calibration which is done over the operating range and meets the requirements. So our next point, our next topic is balance calibration and its parameters. As I told you, there are two general chapters in USP and one general chapter in EP for balances. And calibration and its parameters are given in all these chapters. As per USP General Chapter 41, there are two calibration parameters and those are repeatability and accuracy. As per USP General Chapter 1251, there are four calibration parameters and those are repeatability, sensitivity, eccentricity and linearity. And as per EP 2.1.7, there are two calibration parameters, repeatability and sensitivity. Today we cover only USP 41 and there are two calibration parameters, repeatability and accuracy. So first, repeatability. To perform the repeatability test, a single weight is selected and it is weighed again and again for 10 times. Then standard deviation is calculated for these 10 weights and obtained standard values entered in the formula to get the result of repeatability. Formula of the repeatability is 2 into SD divided by smallest net weight into 100. The obtained value should not be more than 0.10%. So, acceptance criteria, acceptance limit of repeatability is not more than 0.10%. Here, SD indicates standard deviation and it can be taken from the print or we have to calculate it manually. Nowadays, modern balances have the facility to calculate standard deviation directly and give it on the print. Here you can see another one sentence. Smallest net weight. So what is smallest net weight? What is the formula of the smallest net weight? And the formula of the smallest net weight is SD into 2000. Let us understand this sentence with the help of an example. Suppose standard deviation of 10 replicates of standard is 0.00015. Then smallest net weight is equal to 0.00015 into 2000 and it will be 0.300 gram or we can say that 300 milligram. Now, if in case standard deviation is less than 0.41D, then to calculate the smallest net weight with the help of new formula and the formula of smallest net weight is 2000 into 0.41D. Here D indicates scale interval or readability. Suppose Readability of this balance is 0.0001. Now we enter this value in this formula. So smallest net weight equal to 2000 into 0.41 into 0.0001. So obtain smallest net weight value is 0.082 gram or 82 milligram. Now the question is that what is the importance, what is the significance of the smallest net weight? And the answer of this question is that the smallest net weight determines the operating range of that balance. It determines weighing value on that balance. Suppose here calculated weight is 82 mg. So we cannot take any weight below 82 mg on that particular balance. Smallest net weight always calculated from repeatability test. Nowadays, many balance manufacturers in the market who provides minimum weight to be weighed on that balance, but that value cannot be considered. That value cannot be implemented in pharmaceutical. We have to calculate smallest net weight from repeatability test only, and we have to implement this value in our day-to-day good weighing practice. Now, second calibration parameters, accuracy. To perform accuracy test, a single weight is selected and its weight is measured. And after that, accuracy performed with the help of following formula. The formula of the accuracy is certificate weight minus observation weight divided by certificate weight into 100. Suppose here certificate weight of 200 gram is 200.0008 gram and observation weight is 199.9855. Here we have taken analytical balance. As you are seeing, there are 4 digits after point. Now we enter this value in this formula. So accuracy equal to 200.0008 minus 199.9855 divided by 200.0008 into 100. So obtained value of accuracy is 0.00764. Here we have rounded it up, so it is 0.008%. And the limit and criteria of the accuracy is not more than 0.10%. Now the question is how much weight to be used for accuracy test, and the answer of this question is that any weight between 5 to 100% capacity of the balance can be taken for the accuracy test. So friends, today we have learned types and classification of balances as per European Pharmacopoeia General Chapter 2.1.7 and calibration as per US Pharmacopoeia 41. Now we will discuss on other pharmaceutical topic in my next video. Till then, thanks a lot and thank you very much. Have a good day.